Good morning, everyone, and welcome to another beautiful day, starting off with the Nordic Data Science and Machine Learning Summit 2021 and the Machine Learning Engineering track of the day. We're kicking things off with a panel with some esteemed members. Today, I have with me Nastaran, Anders, and Kim. I'm not going to take too much time on introducing them. They'll make a much better job themselves. So I'll pass over the word now to Kim to make an introduction of himself.
Thank you, Errol, and thanks for having me. Great to be back at NDSML. Even though it's a virtual event this year, we hope to be back in a physical event very, very soon. So my name is Kim Nass. I'm based in Norway. I am a marketing science director, data and AI, and working for Group M, which is not a too familiar brand for most people, but if you mention the ad agencies that we work with, like Mindshare, Mediacom, Wavemaker, M6, Grey, etc. We are one of the largest media conglomerates in the world for marketing, PR, communications, etc.
Thank you so much, Kim. So I'll pass the word then on to Nastaran to make an introduction of herself.
Hi, everyone. Thanks for having me, and I hope everyone is doing fine during this time. I think things are getting better. Close to back to normal, hopefully soon. I'm Nastran Gadar. I'm an engineering manager at Twitter. My background is in machine learning and computer vision. I have a PhD in computer engineering with a focus on machine learning. During my career, I have worked on different applications around ML, self-driving cars, robots, drones, biomedical engineering, and most recently ads. So at Twitter, I work on using machine learning to improve our ads quality, both for the users and advertisers. And I'm happy to be here with you.
Thank you so much. And of course, Anders, a short introduction of yourself.
Yeah, sure. So I'm an old guy. I've been doing AI research for 20 years, started in academia and did a PhD for 20 years ago, basically. But mainly been working with AI in industry for companies like Spotify, where we used machine learning and big data techniques to try to optimize different Spotify services. Also have a background in the ad business and marketing, since both of you guys have that as well. So I worked for a company called Campania at one point, where we had basically real-time intelligent marketing, and we're heading up Netflix worldwide in their marketing campaigns online, etc. But now the head of research at Peltarion, where we're basically trying to make the latest type of AI available for all and have better tooling to enable everyone to take advantage of these techniques and find true business value.
Thank you so much, Anders. And by the way, I love your t-shirt. I think it's very suitable for today's topic. It's awesome. So we're going to talk about trends and hype in machine learning model factories and management. Of course, this is a more engineering-heavy day today. Many of the topics we've been spoken about the last few years is operationalizing AI, machine learning engineering's role. But what I want to start off with here is talk about what do we mean by a machine learning model factory, and how does it help organizations operationalize data science, ML, and AI? So Kim, I'm going to pass that first one over to you to start the conversation off.
Thanks. I would say that if you go back, I would say AI in its early phases, you would love to see all those data scientists who are those unicorns who could do everything, who were data engineers, who do the big data platforms, data warehouses. They had domain expertise even, and they were the data scientists who could do the machine learning coding. They did everything. And that was great, and it was great for putting things to the test, to prove what AI could do. And for a lot of these projects, it showed the potential value that AI could bring to organizations. Now, the next step of that is scaling. And when your proof of concept AI project needs to be scaled into maybe hundreds or even thousands of AI machine learning small tests, you need to be able to operationalize it. You need to make sure that the data that is being fed in are constantly updated. You need to make sure that your algorithms are constantly evaluated and scored and ranked, so that you, in the end, can get closer to maybe a real-time view of what is happening and how you can improve whatever part of your business that you're working on. So the factory is a great word. I used to work for Hitachi Vantara, and its platform for operationalizing factories, for instance, was great at explaining this in the sense of a factory and the assembly line that you brought and built products with. And machine learning is no different. It's bringing it into that factory, standardizing it, making it automated and repeatable, and then putting it to scale.
I think it sounds like a very good description, and it puts, of course, very vivid pictures in my mind. Now, Staran, you today work for one of the digital natives that we tend to use over and over again as good examples how to use AI, machine learning. Do you have some examples from your current employer or previous employers or line of work where you could actually relate to some hands-on examples of a model factory?
Yeah, I think that generally nowadays, everything is basically a good example of machine learning factory, because we can get away without building systems the way we used to 10 or even 15 years ago. So I think that, as Kim mentioned, it's very important, like for us at Twitter and at my previous experiences, that we build something that is scalable and we think about automation at different stages of the process. So if, for example, we are building a prototype of a machine learning prediction system, we need to think about how we can automate the training process, how we can automate the learning process, and how we can automate these applications on scale. I think that especially like at Twitter, where we are dealing with real-time users all the time and we have tons of millions of users, it's very important to think about the scalability and automation at every possible step of the way. Otherwise, there's no way that we can serve all the customers at the same time and with quality. So I think every day we are trying to get closer into better automations, like in real factories. And the better job that we do, the better experiences our users have.
Thank you. That's very insightful. So Anders, over to you then. I know your current employer, Peltarion, they talk a lot about these topics as well. Do you have any good examples on how this model factory actually works in the real life?
Absolutely. And one of the ideas we're trying to do is enable domain experts themselves to start to explore and experiment and also operate AI themselves. You know, the time that we can stop being limited or bottlenecked by a centralized data science team or these kind of universal data scientists that doesn't exist, and instead enabling the domain experts themselves to start to work with the data, to build the models and to deploy them and operate them. That is really when we scale AI properly. And we have a number of examples of that, like Sybase, etc., that I can speak of. But let me just say, I actually don't like the term model factory that much. Although I love the idea behind it, but the term itself sounds like it focuses so much on the model itself. Whereas in reality, it's so much else that is so important to get this working. Of course, the data itself is even more important at some point. Actually, the whole workflow around building and operating intelligent systems where AI or machine learning is a component of it, but it's not the whole part. That is really I think, the important part, and that it also provides true business value. So, although I, of course, support the whole idea, I'm not sure, I'm not super enthusiastic about the term model factory. There are lots of other terms like operational AI or AI engineering, or trying to integrate and unify DevOps and MLOps, and this kind of going from CI/CD to CI/CD/CT, having continuous integration, continuous delivery, but also continuous training. That really, in an integrated way, can continue to support and improve the models and the whole system itself in a proper way. I think that's an important thing to keep in mind.
And honestly, I must agree with you there. I don't like the term either. I also think it's hard to put name on things. I know marketers at least love to do that because it's easy to package and conceptualize. But these are very complex topics that we are discussing here today. But I mean, if we take the concept then, and Anders, I think you put it nicely here, having different parts, like you have the data ops, you have ML ops, and all of these type of concepts together. If we don't put a name on it, but let's talk rather about the benefits, because Kim, you were early on saying that we're going from the data scientist, the jack of all trades, and I think all of you others also agree upon that. What are the main benefits and what type of roles would actually be able to leverage these type of frameworks or factories or whatever we want to name them now? So Kim, I think maybe it will be good if you lead with that as well, the benefits of this.
Well, the benefits are, in my mind, the separation. So whilst the separation of the roles again. So whilst in the beginning we're looking at those unicorn data scientists, and a lot of organizations would love to have them in essence, but they were overworked. What I like is to when you put it into a process like we're doing here, the operations process, you're able to separate these roles and you're able to collaborate across teams. So you're able to do more with less. In my mind, I see the change from the feel of a startup to the scale of an enterprise when you're thinking about the ML ops and everything you can do. So as one advantage. The other one advantage I see is the ability to continuously work with data, as Anders rightfully mentioned, and then continuously scoring the algorithm. So you're making sure that your algorithms are always up to date with the right data, and then your algorithms are always scored with the recent data as well. This enables you to take more factual, data-driven decisions in the end on whatever part of the organization or the business that you are looking at. So the more recent data that you have, the more recent the scoring of your algorithms can be, the better your decision-making in the end will be.
Mastara and Anders, do you agree with these statements?
Yeah, I think that what Kim said made a lot of sense. I think it's like apart from thinking about different roles and how we analyze each part, score them, one aspect that is really important is the technology that is changing every day. And if you think about how we separate and modularize these components, then we can think about how we can scale in the future. Otherwise, if everything is entangled and like everything is a big pile of all togetherness of all the information, there's no way that we can improve it. There's no way that we can test and find like better algorithms to substitute. Like if you're changing the platform but keeping the algorithm, there's no way that we can scale it other than having modular systems where each component is working independently, but then we put them together. So I think it's crucial to think about the growth and scalability and moving away from the concept of prototyping and thinking about an actual product. That way, I think it makes a lot of sense to have all these names and make sure that we can validate or evaluate each part separately. And then as time goes on or as new techniques come in, we can interchangeably change these algorithms and build better systems.
Yeah, I'm stumbling a little bit here on my words because I think the recognition factor from my perspective is a little bit close to home. I've been a part of too many projects with the entangled code, impossible to scale. So personally, I love this concept and I really love the points that you're lifting up here. Anders, how about yourself? You've been around for a while. I think you've seen one or two systems that don't scale and you can't put into production. What do you say about the benefits?
What do you mean? Data scientists write awesome code, don't they?
Oh, yes.
Now, of course. And getting away from the AI prototype graveyard we've spoken about so many times is, of course, essential, important. And perhaps the easiest way would be to just give a concrete example. Can give it from Peltorium, and we collaborated with this company called Sybase. It's a small company, but they have invented this kind of tool that they can detect skin cancer with. So they can basically send some current and do some other sensor with some other sensors, especially measure on the skin and try to detect and classify if it's malignant cancer or not. And then they want to use AI in different ways, and we sat with them and we discussed and tried to come up with a good use case to start using AI. And we went through a number of different components of it, and then we came to some conclusion and basically said, from our data science point of view, I think this one really has the best potential from a data and AI point of view. And we sat down and did it, and they tried to make use of it. And then we asked them, how did it go? Did you actually start making use of it? And said, nah, our old rule-based thing actually works rather well, and yeah, we didn't actually use it. But then they said, we actually started to look into some other use cases. And we, as the medical experts they are, domain experts in the medical domain, started to say, we just took the platform, in Peltarian, and we started to use for this use case instead. And that seemed to work super well. And we actually have it in production already. And by the way, we actually have a third one now that we actually start to use. And this was without any collaboration with us, the people in Peltarian, just using the platform, the tooling themselves, and the domain experts themselves actually deciding, what they think is most useful and what they think will work. And, when you can put AI in the hands of domain experts and let them actually do the work in a self-service kind of way, I think that's truly when you can scale the use and bring true value to an organization.
Yeah. I think that was a really good point as well, because I really see the benefit of building up that model library of a lot of great pieces of code. And as you said, if no one tells you that you're writing good code, you just write it in the comments yourself. Because if you separate everything, you're creating templates for later reuse and for building up a library and a catalog of everything that you're building, so that you can more easily build templates that you can put into other, for instance, for other customers or other parts of your business where you can utilize these. So it's a great way of not only scaling within your own enterprise for different projects, but also repeatable projects later on.
Mm-hmm. So what I'm hearing here is that we're starting to talk more about capabilities and reusability and scalability of the type of work we used to put in the hands of one data scientist or potentially two a few years back. Mm-hmm. So let's take that as a segment. What I want to talk about now is becoming a little bit more tangible. Anders, you already made the very strong statement that data scientist is very good at writing code, and I'm going to hold you to that next time I talk to data scientists. But I really want to understand what skills do we need and what type of cross-functional team do we need to build up in order to be able to create this type of setting for the reusability and capabilities. So maybe I pass the word to Nastara now to start discussing the skill setup.
Sure. I think that I wanted to start with the term of data science, and I think that in every industry it may mean like the model factory that you don't like the name, it may mean different things. I have heard that some places data scientists and machine learning engineers have exactly the same meaning, and some places they differ. But I think it's good to mention that for being able to build that scalable system, like having that model factory, the main components that the people need to have is the machine learning knowledge part of things. So meaning that if we were able to build that prototype, what were the features that we wanted to use, what sort of architecture can we use to build this system to predict or do any other machine learning actions. And then there's the platform or the infrastructure of where this system actually lands on. So it's very important to have people with the focus of understanding how to do like training, if it's online training, if we have tons of data, how to partition this data to be able to have like small delays or be able to answer something in real time. Or if there's a bug, we can make sure that we can separate that bug from the rest of the platform. So some infrastructure knowledge and some machine learning knowledge. And then above these two groups, we need the data scientists, as I was saying, that it might be a different concept. So people who can actually get the data and evaluate it, like read the data, analyze it, and talk about where the issues are, where the dashboards take us, and where the metrics are. So thinking about where we can make improvements, where the challenges are, and if it's good enough or not. Otherwise, if we cannot maintain or reuse or think about scalability, for that we need to have evaluation of the system. So I would think that there are, as I said, there are three main parts. One is the machine learning engineers, one is the infra engineers, and one is the data scientists. And then above all, we need researchers to make sure that they are coming up with good ideas, new ideas, and we are not sticking up with old rule-based systems.
I can see that there are some nods and agreement here. So let me ask you this, Kim and Anders. If you agree with the role description on this level, what would be the ratio between a data scientist, potentially a researcher, versus engineering in an organization that want to go full-fledged towards this type of setup?
Difficult. I tend to say earlier that a lot of the times I would see a 4-to-1 ratio of data engineers to data scientists. I'm not sure anymore, and I think it's as a lot of generalization that goes on in a lot of different conversations that you're having. It all tends to become too broad. I think you need to look more into what kind of problem you're trying to solve. Some problems you're trying to solve actually requires more mathematical skills because you're trying to solve more questions than what you have data for. So you need less data, but you need to do more mathematics instead. So you need more data scientists. And in some cases, it's a total opposite direction. You need more data, and you need so much data that the data engineers are being overworked. So I think I think you need to see it on more of a project by project basis and what you're trying to actually solve going forward. And also,
I'm noting down here, it depends. The consultant answer.
I think it always does. But a general thumb of rule, you need more data engineers than data scientists.
And I think that's a very valid statement. So to the people listening into this panel, more engineers than data scientists, at least with today's setup. Anders, your opinion about that? I know I'm referring to your employer here a couple of times, but I've listened in so many times on them. They want to try to solve it, right?
Yeah, of course, we want to enable domain expert, but just thinking, if we still want to build a data science team, there are so many different dimensions that you want to cover, and having the right mix of different skills, I think, is key. So we don't just have one set of skills, but that is not only engineers versus data scientists. It's so many other things. It's also junior versus senior people. Mm-hmm. Also all the different domain expertise areas that you can have, and if you find the right mix of all these kind of different skills, I think that's the proper way to build a data science team. So it's hard to just put a single number on it, but having the right mix that is appropriate for your business, I think that's key. The other point I'd like to make is, yes, we are seeing an increased specialization in different types of roles that we have when it comes to AI. I think you coined a cool one yesterday, Errol, with the AI translator and being able to communicate about AI properly to people, etc., which is super important. But this kind of direction where we keep having more and more specialized role and different people working in very specialized areas, I think is a dangerous one. And I think the better way is to make AI more natural component of any kind of team and person and the skill they have. So it should be, just as we want to unify the process of building AI systems with normal software engineering systems, we should also unify the skills. So people that sits in the management team, they should understand, not the technical details perhaps of AI, but at least the concepts of them. People that are sitting and building back-end systems or database systems or front-end mobile apps, web app, and whatnot, they should also understand AI and be able to use it. we still have a big problem today, which makes it really hard to come there because the tooling is so immature, and that is, what Peltorn is trying to help out with. But there will come a point, not that far in the future, where the tooling is becoming so much more mature that it will be possible for any person to start understanding and even making use of AI. And I think that's the right direction, and that's the proper way to scale use of AI in more long term.
Don't you think that would maybe make people more going to breadth rather than depth?
Well, just as if you take one of your example, like an infrastructure engineer, and they are super specialized in trying to make the whole infrastructure scale and be robust and stable, they may need to use AI for some part and support AI in building that, but they can also use AI to make that infrastructure more robust and scalable. So, it will become a natural component even for infrastructure engineers, I would argue, in the future. So I would argue even you can't be, for example, an infrastructure engineer if you don't understand AI. And to have that skill set distinct from yourself is, I think, in 5 years will be dangerous. Still, you will need AI experts. So, I'm trying here perhaps to make myself unusable, but that's not the case. We will always have need for AI experts to know the edge, that know, what does work and does not work to a larger and deeper extent. But I think it's better that we start to move in a direction where people start to consider that AI is a natural component. Just as you need to understand how version control systems work, you also need to start to understand how using machine learning works.
Yeah, I agree. The general understanding should be there, but maybe like the depth of knowledge for like a backend engineer can differ from like a modeling engineer.
Absolutely.
And I just wanted to add that going towards this, what we're talking about is explainable AI to every part of the organization, and you need that AI literacy, which I think what Anders is trying to say here. A little bit of understanding of what a lot of people refer to data scientists as magicians or wizards, because what are they really doing? They're making some magic, and it's not really magic. It's mathematics, which the Sumerians invented thousands of years ago. It's just we have the capability to do more with cheaper storage and better CPUs these days. So explainable AI is AI literacy in the respect that I see it.
So what I'm taking with me from your conversation now is that it's still an emerging field. We're still seeing new roles and new capabilities and new type of teams being formed. I'm also taking with me here that we need to increase AI literacy. I think that's a good point. Not everybody needs to be an AI expert, but everybody should be aware of what AI is, how it's used, and that it's not magic, it's just math. And then, of course, we haven't seen it all yet. We're probably going to look for a much more T-shaped profiles in the future. People knowing a little bit about many things, but being a specialist in one to be able to form these teams. What I think is really good here is that we're starting to kind of going around these type of questions. What I want to do now before we end, we have 10 more minutes of this conversation, is to talk a little bit about the architecture around these type of systems as well. Because we talked about the type of skills, we talked about the way you're working, how these things actually work in an organization. So technology, architecture. Nastaran, do you want to start with potentially describing what type of architectures are we seeing when it comes to these type of deployment systems? I think we could keep it on a conceptual type of level. It's very hard to go into the exact details, but what are the main components that you see today in order to create these type of systems?
So I think that it's like any distributed system. There are some major components that are pretty similar. Some part that is user facing, and some backend information where we can store the data, we can analyze the data, and we can encapsulate all of these modeling parts into step where when the user sees, they see it as a black box that gives them information, but they don't know where it's coming from. So the way that the distribution may work, it may change, but depend on what business we're trying to do, or how massive our training data is, or how big our infrastructure is, how real time it needs to be, what are the different aspects that we are trying to get out of this modeling factor. And basically, based on the goal of the system, we can decide like how distributed the system needs to be. But I would say that generally we need to have a good infrastructure which we can scale in future based on what we can see for the needs of the users or whoever is basically using the system. And make sure that if we are thinking about real-time systems or we don't care about real-time systems, we have that delay in mind that we need to build something that acts fast, or we need to build something that can be pushed. It can answer in an hour, it doesn't matter. We just care about the accuracy. So depending on the system requirements, we can think about how we can scale and have these components where we can store the data, analyze the data, and finally encapsulate it for the user to be able to use that results that we are generating for the users.
Thank you. So summarizing a bit, what are the main capabilities you see in these type of systems if you were to bring them down just to a concept type of level?
So infrastructure, data storage, machine learning algorithms, and front end, where the user is basically collaborate, engaging with whatever the product is.
Thank you. Kim, I can see that you're nodding here. Anything you want to add to the systems type of architecture?
Yes, I would also highlight the need, especially in a large organization, of having a, I don't know if it's perfectly fits into an infrastructure discussion, but it's a components discussion. It's a data catalog and a collaborative data catalog where you can actually look at all of the data that you have across different stores, databases, data warehouses, data lakes, etc. And through a data catalog, being able to find data sets, discuss the data sets, discuss the data in them before you join them in a user-friendly interface, so that data scientists, engineers, and business users can discuss them. So I think that is a good component. And then having the versioning control system of everything you do is also very, very important.
Definitely. Anders, any comment on the architecture type of setup?
Yeah, I love speaking about tech, as we know.
I know.
But I think what you all said makes a lot of sense. And we're actually having a workshop later this month about the specific topic of trying to unify, DevOps and MLOps and the whole area, as we call AI engineering. So what we're trying to do here and basically do research about is how we can take the traditional software engineering processes that we have and best practices that we have and bring AI into that, so we have more of a unified framework for doing so. And we have so many different techniques. You mentioned so many of them right now when it comes to data storage and having the infrastructure working in a scalable and robust ways and feature stores. But if I were to go a bit more into the research field and state-of-the-art things, which I'd love to speak about, and perhaps could be interesting for people to hear about as well, we can go more into the model building aspects. And there are different ways to do this, the different AutoML things and hyperparameter tuning approaches. And this is actually an area that Hyperight spends quite a lot of time with, because it is a big enabler. Can make it easier for people to build models and have a model that actually works as well as data that you have. And for some people it works to have ready-made APIs, AI APIs that is pre-trained and you can't even tune for your own data, but it may work for some users in that case. In other approaches, with more AutoML approaches, you can train them with their own data, but you can't really customize the model. It's not as flexible as it could be, but at least a bit more flexible. Then you can have a more flexible approach where you can both train your own data and also build your own model in different ways. And that's, of course, where Hyperight comes in and what we try to aim to do. But if we bring, as a last point, a more state-of-the-art thing, which I think is so cool and I think will change so much how we do the building of models in the future, is the area of neural architectural search. So this is an area where you basically can automate how you design the architecture as well. So in short, instead of just training the parameters of a model, you can also train the architecture itself during the same time. Previously, it was super costly and very time-consuming to do so, but with the recent approaches, you can basically, with very little overhead, train both the parameters of the model and the architecture. And then they have these kind of macro approaches or micro approaches. You can either tune the whole architecture itself, or you just try to tune specific components, like specific layers or whatnot. And that, I think, is really cool, because that allows you to, for one, have the human in control, design the architecture as you see fit, and you just press a button saying, please optimize, how big this kernel should be for this convolutional layer. I don't know how big it should be. Just press a button and let them do that. But I want to have control and flexibility in how I design the different data branches coming into the model and how the model looks like. So I think that's an optimal balance between still allowing flexibility and control for the user while still having neural architectural search to automate the different components that belong in the model. That is working surprisingly well today with things like Dart and GDAS and things like that. It's amazing stuff and still very immature and not ready for production. But in a few years, I think we will see amazing progress there that I'm very excited about.
Definitely.
Can I just comment on that? And it's very, very interesting what you're seeing, what you're saying, Anders. And maybe just looking one layer down as well. Have you ever done testing with regards to operationalizing some of the machine learning models that you've created and looking across different CPUs or systems to increase the performance of them? Because I think a lot of people saw that NVIDIA and graphical processors were having an added benefit of being the processor that you're running machine learning code on, especially for CNN networks. But then there's come a lot of specialized CPUs. I have a friend of mine who I worked with at Oracle, who's now a vice president at a company called GraphCore AI.
I know it.
Huge unicorn. You know them.
Yeah.
And it's a great point for looking into what they're doing, because some of that amazing scale that they're doing within their CPUs, at least for really large organizations, can be really beneficial. But have you done any kind of research on this?
Well, yeah, it's so many aspects here, and I'm eager to bring up another Elon Musk anecdote, which I always love.
Just to warn you, we only have 3 minutes left, and I want to be able to do a bit of closing as well. But Anders, if you can make it short and snappy.
Yeah, okay, I have to think here. But, Elon Musk, they also developed their own, FSP, full self-driving chip as well, and they threw out NVIDIA. And so many people are doing that and having very specialized chips and hardware. And then it needs to be possible to abstract away how you program these. And I think what we are seeing now with TensorFlow's XLA, for example, allows you to target the different hardware in a much more automated way. And also what PyTorch is doing with their backends now and supporting one after the other, even AMD GPUs, for example, which I love that they are also starting to support really well, is, I think, a really good direction. So we don't have to, as a data scientist, learn another layer of complexity, which is the hardware, and still being able to have significant improvements in terms of cost and performance by taking advantage of these new hardware. So
Thank you. Unfortunately, we're running out of time. We only have 2 minutes left. So I'm going to do a round of final thinking from all of you. You have around 30 seconds just to summarize how to get started within this field, if companies or people tuning in right now, and also how they can connect with you on top of the networking function we have set up in the platform. So Nastaran, do you want to start with how do you get and what you think about in the field? 30 seconds.
Sure. I think that getting started in AI is very easy now. There are several courses online. There are several tools. I would suggest that people start with a project of their own. Just start simple and build a tree of like a decision tree, something very simple, rule-based, and then go on from there. In terms of communication, I'm available on LinkedIn. I think that my information is there, and let me know if I can help in any way for getting you started in AI or machine learning.
Kim?
Yeah, so I would take the next step in what she was saying, because she was talking about how you can be you can teach yourself on AI. I would say going into a mode of when you want to start with this in your company, think of a strategy first. Getting to grips with what you're trying to do within your organization. A lot of the times, strategy is like the Monty Python sketch of a 100-meter dash for people with no sense of direction. Everybody just piles off in their own way, and you need to make sure they're all good initiatives, all good questions are being asked, and you're pulling every resource into the right direction. So, getting started with a good strategy meeting is always a good start. And yes, my contact details is on LinkedIn. You can search for me there using my name, and I'll be happy to answer any kind of questions that you have.
Thank you. Anders, unfortunately, we're out of time. So how can people best contact you? I know you like to chat about these topics.
Sure. You can find me on LinkedIn or just write an email at anders@altarium.com.
Thank you so much all for participating. Really interesting discussion, and looking forward to many more to come. Take care and enjoy the rest of your day.
Thank you.
Thank you.